So today we're going to be focusing some more on geometry, mainly on 3D shapes and what's happening with those. So surface area and volume with some of our three-dimensional solids. Whole bunch of formulas to review, but nowhere nearly as many as we had yesterday. They're actually all on this slide. So we're going to start off with a sphere, volume and surface area. And I am wondering if we have anybody who remembers the volume formula. Think about the two formulas, which one's which? Anybody brave and want to unmute and say what they think it might be? Um, 4 pi r squared is one of them. What kind of units for volume? What kind of units for surface area? Which one would have the r squared in it? The surface area. So 4 pi r squared is going to be the surface area one. The volume would have cubic units and is going to have r cubed in it. They both have the 4. One of them has an extra 3 in there, 4/3. So what I remember is what I was just talking about with that. Volume has cubic units, so it's the one that has the r cubed. Surface area has square units, so it's the one with the r squared. And both of the 3's are in one formula. The other one doesn't have any 3's. Volume, if it is a cylinder or a prism, we are talking about shapes like you see here that have sides that go straight up and down. Two bases, you can turn it so the roof and the ceiling are the same shape, and all of the sides go straight up and down. And then our formula is area of the base times the height of the solid. We use uppercase letters for 3D shapes and lowercase letters for flat shapes like triangles. So a triangle's area is 1/2 little b little h. Now that we're talking about a solid, we've got the uppercase A, B, and H. Now, if you learned the formula with a big B for area of the base times the height, I don't really care, as long as you are remembering that it is the area of the base times the height. That's the only formula that you need to memorize for the volume of any shape where the sides go straight up and down. If it is a cylinder like this, you would then put a pi r squared right in there for that area of the base. If it is a triangular prism, so that the base is a triangle, you would put 1/2 little b little h in here for the area of the base, and then times the big H. You look at the shape and see what it is that you need to have there. If we want the surface area of a solid, we are talking about the area of all of the different sides of the thing. So these shapes, these cylinders and prisms, have two bases. So we need to put in the two bases. So get the area of 1 times 2. And then to get the sides that go up and down, so all of the walls, it is the perimeter of the base times the height. If it is a circular cylinder, we'll put a pi r squared in there because we know that's the area of a circle. And we would put in a 2 pi r right there for the perimeter. If it is a triangular one, we would put in 2 times 1/2, so that would cancel out and just make 1, and we'd have the little b little h, and then we would add up the 3 sides times the height. We just have to look at it and use what we know about the different shapes. Lateral surface area is when we don't include the bases. So we would get rid of these two bases and just keep the walls, so the perimeter of the base times the height there. Lateral surface area is what we are generally talking about if we're painting a house. How much paint do we need for all of the walls of the house? Not exact, because sometimes we have little parts that stick out on the house that we also paint, so we get, some extra stuff in there, just part of making the house look interesting. And we also don't paint over the windows. We still want to be able to see out of them, but basically that's the part we're painting. We're not painting the roof and the floor. Okay, moving now to objects that come up to a point. These last ones only have one base in there. And so we're talking about cones and pyramids. If we want volume here, it's not going to hold quite as much because those sides don't go straight up, they bend in. So our volume is 1/3 area of the base times the height. If it is a cone with a circle for a base, we'd put pi r squared in right there. If it has a rectangle for a base, we'd put the length times the width in there. If it had a triangle for a base, we'd have a half times little b little h that we would next substitute in for that part of the formula. If we want the total surface area, this time we have only one base. And then we need all of those triangles that slant in until they meet up at the top at a point. The area of any one triangle would be 1/2, and then this base, and then the height would go down through the triangle. It would go out there to the side. That is called the slant height of the pyramid or the cone. The true height goes straight down to the middle of the base. The slant height is going down along one of those slanted sides. This perimeter of the base would be, well, we take one of those triangles and then the next triangle and the next triangle and the next triangle, and we put them all together so that our formula becomes the total surface area is one base plus 1/2 the perimeter of the base times the slant height. If that is a cone that we're talking about, and we don't have to memorize this separately, we would just put in the pi r squared for the area of the base. Then we would have 1/2 the perimeter of a circle is 2 pi r, and then we'd have the slant height, but the 2 and the 1/2 cancel out, and that's why we just have pi r l. And that's a cursive L in there. If we are talking about a pyramid, and again, we don't have to memorize this one, we'd substitute in, we would still have the one base. And then when we are talking about the perimeter of the base, we would take the little b for one side of that base. N is how many sides it has, and if this is a regular pyramid, so that all of the sides are the same, so that the base is a square or an equilateral triangle or a regular pentagon or hexagon. If we just know one side, we multiply it by how many sides that we have, and that's the perimeter of the whole thing. So hopefully I talked enough going along there that you've had time to pretty well stay caught up with those. Write wait if you need me to wait. And let's do a few examples. Okay, so here we have that word. We have a regular pyramid. So all of the sides of the base are the same, and in fact, they tell us that we have a square pyramid. So I'm going to try to kind of draw one here. So that's going to be a square. Drawing it so it looks more like a trapezoid or a parallelogram so that I can make it sort of look 3D. We know each side of the square is 4, and we know the slant height is 5, and we want the surface area of the pyramid. Oh, let's see, it's been too long since I was doing these problems last year. I'm not sure I remember my formula. I'm going to go back and look at it. So surface area of a pyramid, that was farther down here. Oh yeah, that was the one base, and then 1/2 the perimeter of the base times the slant height. So I'm going to write that formula down. I need the area of the base plus 1/2 the perimeter of the base times the slant height. Okay, somebody unmute or type, and I'll go back there. I will go back to those formulas. If you didn't get it enough going back there, I didn't see that. I'll go back in a minute. Somebody tell me, how do we get the area of this base? Unmute or type, your choice. Exactly. So we're going to have 4 squared to get the area of that square. And then we need 1/2. And what do I do about the perimeter of the base? Somebody different, unmute or type. Yeah, we get another 16 and there, 4 plus 4 plus 4 plus 4. So 16, and they tell us that the slant height is 5. So let's see, 16, half of 16 is 8. 8 times 5 is 40. Hopefully I did that right. If not, type it in the chat. 56 and centimeters, and this is surface area, so square units. So hopefully that looks right to you guys as well. And let me go back to the formulas because I didn't see the weight request before I moved on. So get down here at the bottom and just type a quick OK once we're good to go on. And B in this formula, B is one side of the base. If I have 4 sides because it's a square, I need that one side times 4 to get the perimeter. If it is a pentagon, I need one side times 5 because of it being a regular pentagon. So BN is just the perimeter of the base. So N is the number of sides in the base since it is a regular pyramid. Okay, let's try another example then. Let's get some that are a little bit more involved here. So now I need surface area of a sphere. Okay, so I've got to remember the surface area of the sphere. Somebody unmute and remind me what that one was. 4 pi r squared. So all I need to do is plug r in there. No, they don't give me r. Okay, I got to figure out a way to get it. The only other thing they tell me is that the volume is 288 pi. So what was my volume of a sphere formula? Somebody different, unmute. Great, and it's fine when I'm hearing more than one of you at once on questions like that. So 4/3 pi r cubed. Now pi is just a number, so the only variable I have in there is r. So I just need to solve this for r. So one thing I think I'll do is to divide both sides by pi, so I can get rid of those. So now I have 4/3 times r cubed, and we saw a couple of times yesterday that when I want to get rid of a fraction, 4/3 times my variable stuff, I need to multiply both sides by 3/4. So this one will go away. This one, 288, I think I can divide by 4 and get 72 times, and I still have that 3 in the numerator. And help me out here. Anybody know or have your calculator handy? If r, what's the cubed root of 216? Or anybody remember a number cubed? Okay, so r is 6. So all I need to do now is plug that in over here. And 4 times 36, I think, is 144. Times the pi. I simplify everything except the pi as much as possible. And that's my exact answer. I have not rounded. With a calculator, I believe we get 452.389. If you guys have your calculators handy, go ahead and get those turned on so that you can help me with some of those approximate answers when we plug in for pi. Okay, let's try another one. Volume and surface area of a sphere with radius 7 centimeters. So I just need to write down those formulas and plug into them. So let's see, the volume one, that's the one with the cubes in it. So that's going to be the 4/3 pi r cubed. And surface area is going to be the one with the squares in it. So 4 pi r squared. And all we have to do is plug in the 7. So 4/3 pi times 7 cubed. And what you want to do on that is put it on your calculator, 4 times 7 cubed divided by 3. Don't put the pi in there yet. And see what that simplifies to. Anybody have the fraction that that becomes? Thank you. So 1,372 over 3, but we also need the pi in the final exact answer, centimeters cubed. And then on a calculator, 1436.755 when we take that 1372 times pi, and we label those units. Surface area, we also just need to plug in the radius, so 7 squared, I believe 49 times 4 is 196. Punch that in on a calculator for me and somebody call out the answer. And I really appreciate the way you guys are responding to one another's questions in the chat. That is really helpful to me, so thank you. Okay, I'd like you guys to grab problem set number 2, and let's do number 28 together just because it's a horrible, long, messy one. It's not that hard, but there's a lot of stuff it asks us. Type wait if you're still working on example 3. I see several of you and your pictures are grabbing your problem sets for me. And I don't see any weights popping up there. So number 28 looks doggone confusing at first. They've got these 3 different pictures and a whole bunch of words, and we actually need to read the words of the problem. So let's see, what do they want us to do? Okay, so this is just the base of both of these shapes, it looks like. And let's see, we've got the height of both of these is 9 centimeters. And we want the volume of the cylinder, so the one that goes straight up and down. We want the surface area of the cylinder also. So we also need surface area for that one. And then we want the volume of the cone, the one that comes up to a point. Now the second one I can see, oh yeah, it does have the roof and the floor matching the space that we have over here. Kind of hard to see that on the cone, but you have to imagine that the bottom of this cone still has that weird sort of shape in there. And then everything just comes up to a point there. So we have 3 different answers that we need to have for this problem set. Um, I recommend that you do copy all of the examples. That is my expectation, since I'm seeing that question popping up in the chat. The reason for that, you're going to go on to lunch and then other classes, and it may be, 7th hour and this evening before you get time to go back and finish this problem set. And it's very easy to forget, what did Mrs. Smith say? How did she show that we needed to show our work? And if you've got that written down, that's all right there as an example for you to pattern your homework after, and to help things make sense. And yes, we're learning. I can't possibly throw everything in the first day with directions. We're learning as we go along. So from now on, let's make sure we're doing that. So I want to kind of plan my work as I'm doing this. So let's see, when I do volume of a cylinder, I need area of the base times the height. When I do surface area, I need both of the bases plus the lateral surface area. When I do the volume of the cone, I need 1/3 the area of the base times the height. Sounds like I need the area of the base for all 3 of those things. And since I've got one box to write in, I need to kind of plan my work well. I really don't want to find the area of the base over and over 3 times. So the first thing that I'm going to do is I'm just going to find the area of the base all by itself. Even though the problem didn't say I had to do that, I know I need that. So I need to get the area of the base. Let me have somebody help us get started with an idea of how we get the area of that composite shape. It's not just one simple little area. What do I have to do? What's going to be our idea? Okay, I've got 2 semicircles or half circles, and I heard somebody saying something about the middle part. Can you say that again? I need this half circle, so I need pi times the radius squared, so that's going to be a 10 divided by 2. And then I need another semicircle, so that's going to be pi times that radius, so 5 squared, but half of that. And what about the middle part? It is a rectangle in there. We have to look at that. This is a 5 plus a 5, so this side is 10. So 11 times 10. And then let's simplify that. So the parts with pi, I have 100 pi over 2, and I have 25 pi over 2. I'll keep the common denominator. So 125 pi over 2 plus 110. If the problem asked me for that, I would need to label square centimeters for that, but that's not a final answer. I just need that so that I can reuse it in here. So then volume of a cylinder needs to be area of the base times the height. So it's going to be that 125 pi over 2 plus 110 that I just found, times the height, which they told me is 9. So let's distribute the 9. 9 times 125 is 1125 pi, and that's over 2, and plus 990. I can't reduce 1125 over 2, so I can leave it like that for my exact answer and say that that is cubic centimeters. Punch it in on the calculator, and we have 2,757.146 cubic centimeters. And we found one of the 3 things we have to find in this problem. Kind of nice that you don't have to do 29 right beside this one, so if you need a little extra space, use the box for 29. Even with the X through it, I think there's still enough room there that you can write and be able to read it. Any questions on that volume piece? And yes, I am recording, and I'll post this the same place where I assigned lesson 2. There'll be the video there if you need or want to watch that. So let's go on to surface area now. So let's see, surface area, I've got 2 bases. And then I need the lateral surface area, which is the perimeter of the base times the height. So I need 2 times that area of the base that I found at the beginning, 125 pi over 2 plus 110. And now I need the perimeter of this base. So somebody unmute and tell me how I'm going to get the perimeter of that picture on the left. Excellent. And then I'm going to have to multiply that by the height. And I'm really bad when I've got something like that where I'm going to have to get, well, the circumference of this semicircle and then of the other semicircle and then add other 3 things in. And by the time I've done that, I'm afraid I might forget about this h. So I'm going to go ahead and write the 9 down first just to make sure I don't forget it. So then I need half of a circle's circumference. So let's see, circumference is 2 pi r, and I need half of that, so I just need pi r. So that's a 10 pi. And for this one, half of 2 pi r is pi r again, and r is 5, so that's a 5 pi. And then I need 11 plus 11, that's 22, plus 10. Now I've gotten all the way around the whole shape, so 22 plus 10 was 32. Let's see if we can simplify this a little bit now. If I distribute my 2, I get 125 pi, and I get 210, or 220. And if I distribute my 9, let's see, that's 15 pi. 9 times 15 gives me 135, then times pi. And 9 times 32 gives me 288. And if I put my pi's together, I get 260 pi. And if I put my not pi's together, I get 508. Parentheses around it, since all parts of it are centimeters squared. And for a calculator value, and we don't have a whole lot of time left, so I'm just going to go ahead and write that in, 1324.814 centimeters squared. And then finally for volume, I need 1/3 area of the base times the height. And so you're just going to plug in that area of the base and the 9 and simplify that and get me exact and the rounded answers for that.